All right, I think we're live. Give me a second to verify that. Confirmed on X. Confirmed on LinkedIn. And one more confirmation. Yes, confirmed. All right, everyone. Welcome to the Golem 1.3 launch event. So we're very excited to get started today. But before we do, we want to make sure everyone who is planning to join this event has an opportunity to do so. So while folks are joining, I'm going to open it up and ask our Golem team of engineers, not all of whom are able to join us today, but you see three of them here, a few questions. Daniel, what is your favorite feature of the 1.3 release?
Well, I think the new JavaScript engine and the code first thing, these are basically the main new features, but those are all things that we didn't even plan for this release initially. But during this longer milestone, we realized we need to do something and came up with these new features, and I'm really excited about them.
David, how about for you? What's the number one feature in 1.3?
Well, built in on top of those technical solutions, I believe for me the biggest thing is the code first way of coding. It's just really makes iteration fast. When you try to code something, you can. I believe even the previous way was not that slow, but now even in seconds and minutes, you can change your whole architecture and iterate on stuff and call other agents, which is really amazing for me.
Yeah, that's right. How about you, Andrew? What's your favorite feature in 1.3?
Well, I hate to echo exactly what they just said, but I do think Code First Agents is probably the coolest feature, followed up very closely by the debugger and time traveling debugger and the recovery in the console.
Fantastic. Thanks for those great answers. So, everyone, it seems like, is excited about Code First, and we're going to have a chance to show that off in a moment. But we're still waiting for a few more folks to join. So, while we wait, another question. Daniel, what do you think could be the biggest change in 1.3 that might disappoint people who are using 1.2, if anything?
Yeah, probably that we used to support many programming languages and especially focusing on Rust. And in this new release, we only support TypeScript. That is maybe disappointing for some people, but hopefully it's good news for even more people.
Yes. How about you, David?
Well, related to the code first things, so now when I'm inside my agent code, I can just use TypeScript, but still many parts on the CLI, we are relying on the with definitions and with interface names. This might be something which will be a little bit alien or mixed for somebody who is first meeting Golem. So we are still in this transient state, but I hope this will not discourage too many to explore.
All right, fantastic. And not to put anyone on the spot, so to speak, but what is your sense of of all the releases we've ever done in Golem's history, where does this one rank? Is this like a top five, a top three? What do you think?
It's definitely a very important step towards usability. So obviously the Golem 1.0 release was very important because that was the first time that we said that it's production ready somewhat. But this time it's really uh, makes this big step towards not having to learn a whole lot of exotic tools like component model related CLI tooling and specific interface definition language, and all these things are gone. So now you just have to focus on your code. And that's a very big and important step, in my opinion. So it's definitely in the top five or top, I don't know, top three.
Anyone else want to take that one?
I would narrow it to top two or what.
What what beats What beats this one?
I'm
I
not sure. I'm still undecided, but we're pretty close to top one.
all right. All right, fantastic. So I think we've had a chance for folks to join. So we're going to go ahead and kick this event off. And let me start by sharing my screen. How does that look?
Looks good.
All right, fantastic. So welcome everyone and late joiners to the Golem 1.3 launch event. I'm John DeGoes. I'm the CEO of Golem Cloud, and I'm very happy to be the host of this launch event today. And with me, we have Daniel Vygovsky, who's Senior Staff Engineer at Golem Cloud, David Biro, who's Staff Engineer, and Andrew Anderson, who is Software Engineer. So I'm going to have a few minutes at the end to take questions. So if you think you might have questions related to Golem, then please hop onto the Discord, our official Discord. You can find that on the web at golem.cloud, https://golem.cloud. Or if you are very good at picking out these upper and lowercase characters here on the screen, you can join the Discord with the link that you see. If you want to ask questions, that's your only way to do it. So please, I encourage you to hop on over to that Discord server. All right, so today I am going to be kicking things off with a Golem 1.3 overview. And my focus is going to be on the big picture of what Golem 1.3 brings to the table. And because Golem 1.3 is so important and also so radically different than predecessor versions of Golem, I'm going to be presenting this as if Golem were being launched today. So no prior background knowledge is assumed. I'm going to talk about what Golem is all about, what it helps you do, and give you code snippets to understand how you use Golem to solve specific problems. After I'm done, I'm going to hand this over to my colleague, Daniel, who's going to be doing a live coding demo. And I'm super excited about that part because when we launched Golem, I think, a year and a half or so ago with our 1.0 release, Daniel also did a live coding interview, and it took him about 1 hour and 40 minutes to get through that. And so we're going to see how much improvement we have made to developer experience and productivity by having him more or less repeat the feat that he did a year and a half ago when he demoed 1.0. After Daniel wraps up, David is going to take to the stage to walk through Golem CLI, which is one of the different ways that we've provided to manage your Golem agents and your Golem account. And then finally, David will turn it over to Andrew, who will be walking you through Golem Console, which is our web interface to our managed version of Golem Cloud. Obviously, you can grab Golem from GitHub. You can build it on your own. You can deploy it on any cloud that you want. But we are in the early stages of developing a cloud offering that's 100% managed for zero ops, zero infrastructure. And Golem Console is a key component of that vision. And Andrew will give you a taste of where we're headed with that. All right, the Golem 1.3 overview. So this is a mouthful, but let me walk through it step by step. Golem is essentially a runtime for code-first agents that gives you a bundle of superpowers. And those superpowers include automatic state persistence, otherwise known as durable state, fault tolerance, observability, recoverability, and reliable distributed communication. That's a lot, right? And all these features, it turns out, are powered by the same core. Golem is, at its heart, a platform for so-called durable execution. And all of the features you see here and plenty more besides are powered by its status as a durable execution engine. What is durable execution? Well, in Golem case, Golem actually sits underneath your program and executes it instruction by instruction. And a key component of that is every time your program interacts with the outside world, such as calling some function in the operating system, like getting the current time, or accessing the file system, or making an HTTP request, or even possibly interacting with a database or some AI API, all of those interactions are seen by Golem because Golem is actually executing your code instruction by instruction. Golem saves all of these syscalls to a durable log, and that durable log powers observability. It powers automatic retries in the event something fails. Golem can automatically retry that so you don't have to deal with that. If you try to talk from one of your agents to another one, do RPC inside Golem, Golem can make sure that that communication occurs exactly once. And if there is a fault, let's say the server crashes or Kubernetes kills the pod that Golem is running in, or maybe like a CPU catches fire, it doesn't matter. What Golem is able to do is detect that failure and reconstruct the state of your running agent and resume it on a new node, which is completely transparent from the outside. So all of these superpowers, durable state, fault tolerance, observability, recoverability, reliable distributed communication, even the ability to rewind your programs and restart them from an earlier point, which is sometimes important for AI applications, are powered by Golem's status as a durable execution engine. And there's a lot of great durable execution solutions out there. Golem is a bit different in that it is transparent. You actually don't need to use any SDK in order to get durability. All the code you write with Golem is 100% durable, and you don't have to program in any DSL that's embedded inside another programming language. And that arises from the fact that Golem directly executes your program instruction by instruction. All right, well, I've said a number of times Golem is a runtime for code-first agents, which kind of begs the question, what's an agent? Well, I like to think of an agent as a bundle of three things. So an agent is some sort of business logic or code, and that's the stuff that you as a developer write. And then it's state in memory, which is the sort of in-memory state of that agent. It could be stuff that you're storing in memory, or it could be the context. If you're using an LLM to build this agent, it could be context, conversation history, other types of things like that. And then whatever sorts of prompts you're using to interact with an LLM, or an image generator or video generator, et cetera, together with all the configuration. So really, agents are bundles of business logic, state in memory, and prompts and configuration. Now that tells you what an agent is, and I'm about to show you what it looks like, but before I do, I want to give you an intuition for what an agent is and how it can be used. And to do that, let's review a few key points. First off, this might surprise you, but agents can either be pure logic, or they could be a mixture of logic, that is code, and AI. Golem's agents are code-first agents, which contrasts with so-called prompt-first agents. A prompt-first agent is nothing more than a prompt that is then executed by a general-purpose AI agent that's capable of using any one of a number of tools that are built in or that you supply. In a prompt-first agent system, your only way to influence the agent is to actually write tools and to expose those tools to the agent and then maybe to tweak the prompts. Golem is more on the code first side of things, giving you total control over the entire process and allowing you to use LLM where it makes sense, but also not use LLM where it doesn't make sense or where doing so would lead to a suboptimal reliability experience. Golem's agents are capable of orchestrating workflows. So actually, agents are a superset of workflows. You can use an agent in a very trivial way to execute some sort of long-running workflow. Agents are distributed in Golem across a cluster of computing resources, and that scales to millions or tens of millions or however many agents you need. Agents are a bit like, for those of you who know this, and I know some of you do, agents are a bit like durable distributed actors. Every actor has state, right? And they can talk to each other using messages. And in that fashion, agents are a bit like that actor, but with baked in durable state and with exactly once communication semantics and all the other nice properties that I've talked about. And finally, this is a bit subjective, but in my opinion, agents are the fundamental building block of reliable, stateful, distributed systems. Whether you're doing AI agents or just pure code agents, doesn't matter. If you're building a distributed system, then agents are the fundamental building block of reliable, stateful, distributed systems. Okay, so what does it look like? Let's take a look. here is code first agents in Golem. And this is with our brand new 1.3 release. 1.3 is the first release to support TypeScript. Actually, that's the only programming language we support. As Daniel mentioned earlier, we're going to add the other ones back over time. But for now, TypeScript is the only programming language we support. And this is using a new Code First Agent SDK, which you can barely see in this example. Most of the code you write that runs on Golem is going to be 100% TypeScript, executing in a native TypeScript environment with all the stuff you know and love. However, there's a few parts of this example here that are Golem specific, and that is this agent annotation here, which basically turns this into a distributed agent. And then these descriptions, and there's a few other different decorators you can use and attach to methods to sort of provide hints for AI systems that are interacting with your system. So very simple and ordinary code, right? There's two components here. This thing here, the class here, is referred to as the agent type. So in a large code base, in a large AI-based application or non-AI-based application, you might have a lot of different types of agents. In this case, this example has a single type of agent, and that type of agent is called shopping agent. There are two very important components of every agent. One is the agent type, which is basically the class name for TypeScript. And then the other one is the constructor parameters for that agent. In this case, this constructor has a single parameter called user ID because it makes sense that every user in an e-commerce application would have a single shopping agent. The combination of these two things, the agent type and the constructor parameters for that agent type, form the identity of agents inside a Golem cluster. This is a unique feature of Golem, is that every single agent that is running inside Golem is uniquely identified, and that unique identifier, you actually choose it. You get to choose it. And that unique identifier is the combination of your agent type, class name in the TypeScript SDK, together with all of the constructor parameters. So here, shopping agent plus some concrete string would uniquely identify every agent of type shopping agent inside the Golem cluster. Why does agent identity matter? Well, it matters because Golem is a platform for building distributed multi-agent systems. And one of the things you can do with Golem is you can address agents individually. So agents can talk to other specific agents. And when you have an API out in front of your Golem cluster, this API can trigger and interact with specific agents. And those agents are identified by their unique identity, which is nothing more than the agent type and the constructor parameters. So you have precise control over how that happens. This also gives you a way to create so-called cluster-wide singleton agents, which would simply be a constructor parameter list that's empty. If your constructor has no parameters, then you have exactly one entity of that type which runs in the cluster. And you don't need to supply any parameters to address that agent because there are no parameters to supply. So one of the superpowers that you get out of Golem is automatic, transparent, and invisible fault tolerance. What does that mean? Well, many times when we're designing distributed systems, we need to interact with lots of third-party services. And this could be, as it is in this example, code that you write, but it could equally be a bunch of tools that are being invoked by an AI agent. Either one works. The point is that in order to make reliable multi-system transactions that in this case span everything from generating an order ID, reserving inventory inside a warehouse, charging the user for the order, generating a shipping label, dispatching the order to the warehouse for fulfillment, storing the order in the database, and then after all of that's done, sending a confirmation email to the user. All of that stuff needs to be done transactionally, reliably. In order for this to be well-defined, we've got to do all these steps or none of them. And in Golem, you can actually take that property for free. If you write 10 lines of code, they will all be executed atomically. And you won't have to worry about whatever is happening at the layer of infrastructure. If things crash, if CPUs catch fire, if a zone goes down, an availability zone goes down, none of that stuff you have to worry about because Golem is supervising everything that's happening. And when it detects a failure event, it automatically restores that agent from the exact line of code that it left off where the failure event occurred. What this means is you get extraordinary degree of high reliability without having to do anything. You don't even have to use a weird SDK, right? You don't have to do anything other than write ordinary TypeScript code. And in this example, as simple as this code is, it does an incredible amount that would take you probably weeks or months to accomplish using an event-driven architecture where you're explicitly modeling your application as some sort of finite state machine with different states, and it's triggered by all these events which are written to and read from durable logs that are distributed like Kafka. You could do all that, but why would you? When Golem gives you fault tolerance for free over 100% of the code that you write AI without you having to lift a finger. Another thing that should be pretty obvious if you understand the basic idea behind durable execution is that Golem gives you durable state for free. In this example of a shopping agent, all I did was push this item to the shopping cart, which is an in-memory array of shopping cart items. That's it. I didn't actually store that information in the database. Why? Because when you're working with Golem, your agent's state is durable. It's every bit, even though it's ordinary just vars in TypeScript, it is every bit as reliable as a database. So you actually don't, in many cases, you don't need to use databases unless you strictly need them for other purposes. You can rely on all the information that's stored inside this agent because it's always going to be there, regardless of whatever happens to the underlying infrastructure. This is a superpower in two ways. First off, it enables you to dramatically simplify your infrastructure. Delete your databases in many cases. And then second off, it's much easier for AI to generate code like this without complicated SQL updates and touch points and whatnot. AI can very easily generate code that can run on Golem and still be reliable because simple dummy code runs reliably on Golem. Another superpower that Golem gives you is type-safe RPC. We actually call this agent-to-agent communication, and it's 100% type-safe for cases where you are writing some business logic in your agent, and you want to call some other business logic in a different agent, or maybe you want to call some AI that's inside a different agent, and you can do that through well-typed interfaces. In this particular example, we have this user history agent, and for every given user, there exists a single agent in that cluster, which is responsible for storing the history of that user's activities on the e-commerce platform. And if I want to call into that agent and add more things to its user history array, then all I have to do is call this get method on user history agent and provide the user ID. Now I am talking to, in a completely type-safe fashion, a remote agent that is executing somewhere else in the cluster. And every single method I call on that remote agent is actually RPC. It's 100% typed, and I get exactly once communication semantics, regardless of failures that might occur on both sides. The node running the remote agent might go down, or my node running this agent might go down, doesn't matter. I still get exactly once execution, communication semantics from all my interaction with other agents running inside a Golem cluster. And it could not be easier to use this. You can see how much code is required. It's no code. And then finally, Golem is, of course, designed for code agents, but it's also designed for AI agents. And in order to help bootstrap an ecosystem around there and help you decide intelligently where to incorporate AI features inside the Golem agents that you write, Golem ships with a variety of typed interfaces that are vendor neutral for lots of different pieces and building blocks of AI agents. And all of these are vendor neutral in the sense that you can program to the same interface and you can swap in Grok or Anthropic or OpenAI or Olama or whatever else you want. You can plug in all these different models. You can plug in all these different databases, all these different search engines. Your code doesn't change. You just push different buttons in order to say what you want to use now. Our AI support includes support for large language models, of course, including tool usage, graph databases and search engines, web search engines, speech to text, video generation, and code snippet execution, which covers already a reasonable subset of all the things you need in order to build very powerful AI-based agents. In this 1.3 release, it is the first release in which we've actually taken a lot of the feedback of prior releases and poured it into a solution that is really focused on agentic use cases. But we're not done there. We have plenty of great stuff queued up in the pipeline for a 1.4 release, including push-button export of Golem agents to MCP servers. So all the code you write in any agent, you're going to be able to push a button, and now Claude Code or ChatGPT or any general purpose agent can now call into your agents and interact with them without you having to write any code. Code first custom HTTP API. So if you need a custom API over all this agent stuff and you don't want to use the built-in one that we give you for free, then you'll be able to do that in a code first fashion. And we'll be re-adding support for Rust. And we also hope to make progress towards both Moonbit and Scala support in the 1.4 release. We'll see. And then, as demanded by our users, we will support more of the Node.js environment for TypeScript. Right now, we support some things, but there's a chance that whatever you're using on Node.js might not yet be supported. If that's the case, then please reach out to us, and we'll be happy to add that stuff on demand. All right, so that's my rapid overview of Golem 1.3. And before I hand this off to Daniel, I am going to see if there are any questions on the Discord. Let me open up the Discord. It looks like no questions on the Discord. It looks like no one joined the Discord, so no one was able to remember that string of character combinations in order to be here. Either that or you all have no questions. In any case, I'm going to go ahead and hand it over now to Daniel, who's going to do a live coding demo. Daniel?
Thank you. So before I share my screen, just let me talk a little bit about what I'm going to do. As John mentioned, I'm going to write the same application that I tried writing on the Golem 1.0 release event. And there will be two main differences. One of the differences is that last time I tried to demonstrate that we are supporting multiple programming languages and they can work together in a nice way. Now it's only TypeScript, so I will use TypeScript for the whole of the application. And the other difference is that actually now I'm hoping to be able to completely implement it and not just suggest the end of the implementation as last time. And also I will add an extra feature that we didn't have last time, which takes advantage of these AI providers that John mentioned in the end of his presentation. So the application itself, I'm calling it a collaborative list editor. It tries to simulate something more interesting, like a collaborative document editing system. The document here is going to be just basically an array of strings, but multiple users can connect to one of these documents and simultaneously add and remove items from it. And we are going to expose a poll interface where you only get the changes since your last poll call, all the changes that were made to the document by anybody. And we are going to implement an list archiving feature. So you can archive these lists. They get stored in some kind of archive, and you can no longer edit them. And there will be some kind of notification system where if there are connected users to your document and they are not making any changes for a while, then these connected users are going to get an email notification about, hey, you are connected and not doing anything. Not a feature that I would add into a real system, but why not? And yeah, and in the end, we are going to add one more function to this whole thing where you can ask an LLM to add more items to your list based on the existing list of items. So let me share the screen now. And switch to my terminal. So I'm going to use a locally running Golem server, which I already started, but the whole thing would also work on the hosted Golem cloud. And I'm going to use the Golem CLI, which David will talk more about. We start by using the Golem CLI to create a new project, and we can do that by using Golem app new. I will call it demo and choose from the list of available languages. And there are a couple of templates already that you can choose from. I'm choosing the default one because I will get rid of the whole code anyway and write it from scratch. And I'm calling this thing demo call list. It's always a combination of a namespace and the name, and collaborative list editing is something that I gave this as a name. So create application. As you can see, it's running an npm install at the first step. And we have a directory called demo now with some contents. Before checking what it is, just let's verify that we can build this with the CLI. It's doing some things. And eventually, yeah, build completed. So the generated project works. So let's get to the IDE and take a look at what it created. It might look a little bit complicated first because it has this common TS and component TS directories, and within the components TS, we have this demo calls, and that is the actual place where our generated source code is. It's not that complicated. The reason for this is that each Golem application can consist of multiple components. I'm not going into details about why we would do that. In large projects, it makes sense to separate your application to multiple components. We don't have to do it today. So we can just basically write TypeScript files into this directory, and everything else will just work. Another thing before we start writing code is to take a look at the CML file. By default, the templates are coming with an HTTP API section in their YAML files. This basically defines an HTTP API that is mapped to your agent that is implemented in TypeScript. So here, this template is implementing a very simple counter with a single exposed method that is just incrementing this counter. And this HTTP definition exposes that as a post endpoint. We are going to remove this increment method, so I'm just commenting this whole thing out. In this demo, I'm not going to expose anything through HTTP. We don't have time for that. So let's see. This is what John already showed in his presentation, that we have this agent decorator and the class that implements an agent. So let's just start writing something that can evolve into what I just described about the problem. So I will call it a list agent. We don't need these things in it. And yeah, we can still have a name as a constructor parameter because we want to have an arbitrary number of lists in our system, each identified by a name. So that's good. And as I said, the list itself is just an array of strings. So we just add that as a field into our class. And we can add some basic operations like add. Yeah, and fortunately, the AI already knows what I want to write here. And we can add the delete. and the get. And this is wrong. Yeah, so this is the simplest thing I could imagine that basically implements this list editing. We don't have yet the connected users or archiving or any of those things, but it stores a list of items and you can add, insert, and delete and get the items. So let's see if this is enough to get started. Oh yeah, here we have to also return the number of elements. Okay, so let's go back to our CLI and build it again. And while, yeah, it's successful. So the easiest way to try things out with Golem is to use our REPL. And if we start it, it asks if we want to deploy this thing into our server. By default, the server is how I configured it is that it's communicating with my locally running Golem. And that's it. And as you can see, it prints the available exports, and those are corresponding to the TypeScript methods that I already added to our list agent class. It might be confusing that it uses these kebab-cased names for instead of the original class name, and that applies to the method names as well. It has some technical reasons that exist in this version, and in future versions we are going away from that. So eventually you can imagine that you will see exactly the same names that you have written in your code. But right now it has to be kebab cased. So what we can do here is create a list like this, and then add an item to it, and other, and insert one after the other, and then get the items. So this works. And the nice thing about this is that because Golem is a durable execution platform, this is already a persistent solution for managing lists. You can have as many lists as you want, and their contents are preserved forever. I could kill the server now and restart it, and actually I will just kill it and restart it and start the REPL again and get an instance for the test1 list again, and just see that it has all the items that we added previously. So this is the first version. Let's get back to our editor and add a few more things just to be sure that we are matching the original demos feature set. And to do so, we are going to need to add this concept of connected clients and then so on. So let's define a few TypeScript types first. Like we will have client ID, which is just a number. Client information is going to be the ID and an email address of this client. And then we're going to have something that describes insert parameters and something that describes all the available or the possible changes that we can make to a list. And then I'm going to add a map to our list agent. Let's call it clients. And yeah, it's going to be a map of client ID to something that I will call editor state. And what editor state, or it could be client state, but let's call it editor state. Type editor state. It's describing the client itself, and it's describing the changes since the last call. All right, so what else? We will need something to track the client IDs so we can associate new ones. And I think that's it. Oh, and I'm also adding, going to add some error handling. So let's define a type list error, which I'm going to extend later, that we can use to report back if you are trying to do something with an invalid, not connected client. So two new methods here. One is called connect with an email. Yeah, so what I'm going to do is return a new client ID and also return the current existing items. This is important if you are actually try to use the poll API, because you need to have some baseline for that. So we just increment the last client ID and add this thing into the map and return the ID and the current items. So that's the connect function. And the disconnect is even simpler, where we can just take the client ID and delete it from the map. And then what I'm going to do, so we want to handle errors in these methods. You can do it in any way. I mean, you can use any types for communicating back errors for the client, but we have a type in the SDK called result, which is nothing very special. It's just a tag union of an OK value or an error value, but I'm going to use that because it has some nice supports in the REPL and in the CLI to, I mean, it will recognize it as a result type and make it nicer to use. So let's say add is going to be a result, which is either returning the number of items or an error. Same thing for insert and delete. And we can create a helper thing for this. Let's say, what was I calling it before? And sure, can edit for a given client ID. We can have an inner function that returns an error for a value and have a, yeah, and then we can just check if clients has ID, or if it doesn't have ID, then we return an error. Otherwise, we return the inner thing, and then we can implement this in a concise way, like return this and edit ID. Yeah, we need to add an ID parameter, of course, each of these. Yeah, something like that. And it has to be result. Okay. Yeah, and the same thing for this and this. And here, here. And that should work. What's happening here? Oh yeah, we have to pass the ID. All right, so this, and we didn't edit the poll yet, so let's add the poll, which is just going to take a client ID and return a result of set of changes or an error. And here we can use the same thing to ensure that we are connected. And then just get this. Like this, and reset it. So in the next poll call, we are going to only get the new changes, and that's it. So let's try this out again. So one thing that after we build this, we can deploy the new version, but we already have a list that is running. So I'm going to use the reset flag here, which is basically saying that let's get rid of all the existing list agents that we already created and start from scratch. I'm doing that because we completely changed the interface, so there is no other way to reuse the existing ones after upgrading to this new code. So let's try the REPL again. As you can see now, it lists all the new methods as well. And it lists that it uses this result keyword here to indicate the ones that are returning an error. So let's just try this out very quickly. List agent test one. And now we have to connect before we can add items. So let's say I'm connecting with an email address. And let's say John is also connecting. And now we can call add, passing an ID that was returned from the connect, and just add an item. And add another item. And then John is also adding an item. So this still works. Now we can also use this poll thing. So if I'm polling for all the changes since we joined, then it's not working because I forgot to write the code for that. So let's exit this, get back to the editor. So we're never adding anything to these changes. Let's fix that. One way to do is to define this add event method and just go through all the clients and add the change to all of the connected clients. And then we just have to call this in 3 different places in the delete and in the insert and in the add. So let's try to fix it. No, let's just do it from the scratch. That's safer. I will just do the same set of operations, so I can prove you that it works. Yeah, so what I said, just call the poll method with my ID. And I didn't call it with John's ID. And now if I'm adding one more item, and I call the poll again, it's only going to return this new change. But if John is calling the poll, then it returns all the 4 for him. So that all works. Oh, and one more thing that we can try is disconnect. And now if I'm trying to add one more item with my ID, then it's returning that it's an invalid client ID because it's not connected anymore. Okay, so this is also working. And now we can get to the more exciting part where we are implementing the list archiving. And to do that, we are going to need a place where we are storing the archive lists. And for that, I'm going to create a second agent in my component. And I'm going to create a new file for that. It could be in the same file, but I prefer separating them to separate files. It's easier to read and browse them. So yeah, it's going to be, yeah, first I'm defining, yeah, AI is already suggesting that I should define a type that is just a combination of a list name and its items. And then I can create this agent that contains a list of these archived lists. And as John mentioned earlier, by not having a constructor parameter, I don't even have to write this out, but by not having any constructor parameters, we are defining a cluster level singleton. And this is exactly what we want with the archive agent. We want to have millions of different lists, but when you are archiving them, you want them all to be saved into a single place. Obviously, that doesn't scale perfectly for millions or billions of lists, but that's just for the sake of the demo. There could be tricks to shard this or something like that. So in this new agent, we are only going to implement two methods. One is add, which is very simple. It's just pushing the new list to this archive, and the other is just returning all of them. And that's it. And now how we use this is we go back to our list agent, and we are going to add one more agent method called archive, which is going to return Boolean. And yeah, I also said that we don't want an archive list to be editable anymore, so I'm adding a flag for that. And check this, yeah, add the new error type, so we can indicate that it's already archived and handle it in this ensure can edit method. If this is archived, then return an error saying it's archived. And here, if this is archived, we return false. Otherwise, we are going to set it to true and return true. And here we have to somehow store the list in the archive. So this is very easy with the agent-to-agent communication. What you do is simply first we have to import this agent type archive agent from the other file. And once we have that, we just get a reference to this remote agent by saying archive is archive agent.get. And then we just call the method on it. Yeah, and one more thing is that this is an async function, so we await it and make this async. And that's it. We can print the message that we arrived it, and that's it. That's all. We implemented this feature as well. It has to be promised. Let's try this out. Once again, building the thing. And now I'm going to show something different than before. Golem app deploy, but with update agents. Although this is going to, instead of dropping the existing list that we created in the previous REPL session, it's just going to update it to the latest code base. And we can do that because this whole archive functionality is an incremental feature. It's not going to break anything to use the latest code base interpreting the state of the previous list. So let's try that. Agent update is pending. Agent update succeeded. It didn't succeed because I changed something, I guess, that I'm not going to figure out in this live demo. So let's just start from scratch. Sorry, I must have done something differently than in my previous practice sessions. Anyway, it's now deployed. Let's try the REPL again. Now it shows that we have archive agent and not only list agent. So we have the latest version. And let's just quickly create again a list. And I'm connecting. And I'm adding 2 items. And now I'm archiving this thing, which says this test1 is archived. And if I try to add one more item, then it's not working anymore. And we can get a reference to the archive agent. Archive agent. which is a singleton, so we don't have to pass any parameters to it, and just see what are the archived lists at the moment in it. And it has our test one. And I will also create one more list just because I want to show something after this. Test two. I'm connecting to this one as well. Now what's happening? We are waiting for something. I'm not sure what we are waiting for. All right, so let's see. Golem agent list. Yeah, well, two things I wanted to show. Golem app agent type list. No, list agent type. It's showing that we have two different agent types in the system. And if we type Golem agent list, that's what I wanted to show, that now we have two agents that are two list agents for our two lists, but we only have one instance of the archive agent. And if we archive the test two as well, which we can try. List, okay, test two is not working for some reason. Anyway, demo effect. Yeah, so we are implemented the archive thing. The next thing that I wanted to implement is this notification feature, and I'm not going to type that in. I'm going to copy what I prepared because just it's otherwise it would be boring, but I will explain it in details how it works. It's also just a few lines of code actually, but not that interesting to type it in live. So let's go into this directory, just copying one more agent. We are going to define one more agent for that, and I'm going to explain why in a second. So what we basically want to do is that we have our list, and whenever now nobody is adding any changes after a while, which in this demo is going to be just 1 minute, we are doing something. But it's very important that in Golem, these agents are running the external calls of these agent methods sequentially, and there is no way to run something in the background on the same agent. So if you want to do things that are running in parallel, you have to think in multiple agent instances. And what we are going to do in this case is that every time you create a new list, you also spawn a notification agent with the same name. So that's kind of a sidecar of your agent that is running in parallel to your list agent. And that is going to communicate with your list to figure out when it has to do the notification itself. So the notification agent that I'm defining here, yeah, we have to export this class so it can be accessed there. It's also an agent, also identified by the same name, that is the list name. And it only exports a single run function. And this run function is going to contain a loop. So this is a long-running function that basically is continuously executing during the whole life cycle of your list. And that sounds expensive, but it's not really expensive in Golem because this thing can sleep. So in the example where our deadline is going to be just 1 minute, it's not that efficient, but imagine that in a real world scenario, you only want to send these notifications after hours or something. How do you do that? You can, in Golem, you can just sleep for as long as you want. And while you are sleeping, your agent is not going to consume any resources. And Golem guarantees to wake it up in time even if the server restarts or anything happens. So here what we are doing is we are going to ask our list about what the current deadline is. The deadline is going to be just a point in time when we want to send these definitions out. So let me go back and copy that code as well from my prepared example. Yeah, this one. So we are going to have two new fields in our class, last notification deadline and last notification recipients. And we just update this after, first of all, in the constructor and after every editing. And that's going to be here and here and here. And what this does is that just get the current time, add 1 minute to it, and just take a snapshot of the currently connected client's email addresses. And then we add this new method here, which was called getCurrentDeadline. And that, if we are archived, it's just returning undefined, otherwise it's returning these two values. And with that set, we can just write this loop. We are asking the list. If it was archived, then we are done. We are closing this agent as well. If it was not, then we check if the current time is after the deadline or not. And if it's after the deadline, we are sending notifications to these recipients. If not, then we are sleeping, which is here implemented with this promise that gets fulfilled by a set timeout. And in the send notifications, we are just using SendGrid in this example to make a regular fetch call, your usual JavaScript fetch, to use the SendGrid API to send an email and print something. So that's it. And one more missing part is who is going to call this run. But as I said, it's just every time we create a list agent in its constructor, this is not my new code, sorry. Here it is. Yeah, so what was seen there is that we import the notification agent here, so we can call it. And we create a new notification agent with the same name as our list's name. So it's not a singleton like the archive one. It's one corresponding notification agent for each list agent. And then we can call the run function on it. But as I said, these things are awaiting for the results. So if we would do this here, then we would basically block our constructor forever because the notification agent is supposed to run forever or until our list agent exists. So this is not the way to do it, but we can instead use the trigger function here, which says, I want the run method on the notification agent to run, but I don't care about the results, and it returns immediately. It's not even an async function. And that's it. So I'm just not sure what happened before, so I'm just going to restart the server in a clean state. Sorry about that. It's probably not necessary. I'm just probably mistyping something that I don't see because of the stress of the live demo. But let's compile this from scratch. Go app build. And now let's deploy it and try out in the REPL. And just taking a look at my notes here. Yeah, so, okay, let's create a list. Add an item. And at the same time, I'm going to, oh, where I am. Okay, so I'm going to see the list of agents. And I have this notification agent here now, and it's suspended. It's suspended because it's sleeping, waiting for the 1 minute deadline to elapse. And I can use Golem agent stream to see its console output actually. So we can see that it already asked the list once for the deadline, and now it's sleeping. And if I'm talking a little bit more, then it's supposed to wake up and realize that the deadline elapsed and send the notifications. Yeah. So it was trying to send the notifications, and SendGrid returned with a 401 because I didn't provide an API key. So if we go back to here, as I said, we just use fetch, and then I didn't really talk more about this. But here we are taking the API key from the process environment variable, Node.js process libraries environment object from SendGrid API key, and we didn't set it to anything. We could. I will show it how. So in the same YAML that I showed in the beginning, there is also an environment part. And here I could say SendGrid API key and either type it in here directly or refer to a real environment variable from my host system. And I have this defined in my system. So if I would rerun the whole thing like with this configuration, then it would actually print 202 or something that the SendGrid accepted my email request. But I'm not going to spend time on that. You can believe me. And now basically we are done with what I had in the Golem 1.0 release event, except that in that one, there was no actual email sending implemented, and now we have that. So I thought that just very quickly, not manually writing the code, but I will also show just a glimpse of how these AI integrations work in Golem. So let me define one more agent that I call it the AI agent, maybe. Copy pasting here. And let me go through that. So it's also an agent class called AI agent, also identified by a name. But on the top of the file, we are importing this LLM library, which is a vendor independent abstraction over various LLM providers that we provide that we support in the Golem TypeScript agents. And we are exposing a single method called extend items. And what it does is that first it creates a remote agent reference to our list by using the same name and just gets the current items from our list. Then it constructs a message for our LLM asking to generate more items that are similar to the existing items and asking it to return in JSON. Just we are selecting a model, we are customizing some options, and calling the LLM.send to send this to some LLM provider. And then we just process the response and parse it as a JSON. Then we use our list agent public API to connect as a fake user. It's not supposed to be called fruits because, yeah, I was using fruits as an example. Items is better. Yeah, so items, going through the items and just calling list.add on each and then disconnecting. So that's supposed to extend with a number that I asked in the prompt somewhere. Yeah, 10 more items to the list. And then we just expose this in our main list agent as one more public method. Let's call it extend, async extend, and that's just going to create an AI agent with the same name, and then use the same technique to trigger the execution. Because with AI, these LLM calls are slow, and as I said, these invocations to an agent cannot overlap. So we want this to be executing in the background. So we just create a separate agent for this that can run however slow it wants, and just trigger this execution, and it's going to get back with and add the generated items one by one in the background. And that's it. Let's try out. Oh no, we cannot try it out yet, because if we would, it would fail with, we were using LLM, but we never specified what LLM provider we want to use. So what we need to do is go back to this YAML file, and it has these commented out sections about all these providers that we support. And if we look for OpenAI, it has this link here prepared. So we only have to uncomment this. If you want to use OpenAI, we could use Anthropic, we could use OpenRouter, Amazon, and so on. But in this example, I'm going to use OpenAI. And the other thing we need for this is an environment variable with the OpenAI token that I have, which can be added like OpenAI API key. And that's it. So let's try this out. I also deployed a new version. Actually, you don't always have to write build and deploy and all these things. David will talk about that, I guess, but I like to explicitly show the steps. Golem REPL, and then just let's do this example of defining a list of fruits. And add a few examples. And then see what fruits we've defined so far. And then call this new thing that we just written. And then on a separate tab, we can agent stream AI agent fruit. And yeah, we can see that it already added all these different fruits to our list. And if we now just call get again, we have them in our list. And that was the last thing that I wanted to show you. This whole example application is going to be available on GitHub to play with. And with that, I would like to hand it over to David, who is going to talk more about the different features of the CLI.
Hello, everybody. So I'm David, and I will, as you know, I will give a short tutorial about the Golem CLI. And this will be not an exhaustive enumeration of all the features and comments what the CLI has, but rather I would like to show you enough that you can start exploring your own. And also I would like to make sure that you will know, as Daniel mentioned in the previous demo, and he called these commands separately. I want to show you what is the fastest feedback loop, what is the shortest developer experience you can have when you are iterating on projects and agents. And let me share my screen. I hope you can see it. So,
yes.
Thank you. And let me hide it. Okay. So even before going into what commands we have, the first command I would like to show you is the Golem completion, which actually will generate you a different shell completion script. And there's a tip. The first tip is usually if you don't know what to type in somewhere, just type something silly and see what happens. And of course, the shell will help you, or the command line will help you. And you will see that we have shell completions for different popular shells. I do use Z shell, and I already installed it for myself. So I can actually give you a quick tour around what kind of main commands and subcommands we have. As you can see and understood from the previous demo, we have components, which are kind of like containers for containing agent definitions, which can be then created and invoked through the agent constructors. And then, which we didn't talk much about, you can also define HTTP APIs by gluing these agent calls into an HTTP API, where the APIs are created as API definitions, then deployed together to a specific server. And of course, you can see we have other things like cloud certificates and domains, which are specific for our cloud environment. And another thing which I would like to talk as the first main thing to explore are profiles. Golem profiles are a way to select what kind of server you are trying to talk with, and also profiles can be customized to your taste. Let's see, let's just list these profiles. We can see that we have two built-in profiles. One is the Golem Cloud, which is our hosted solution, and one is the local. You can see that I'm using the Golem executable, and we actually offer another one called Golem CLI. The main difference between the two is the Golem CLI. So the difference is that Golem includes everything what we have in Golem CLI, but Golem also has a built-in server embedded inside the Golem executable. This means the binary size is a little bit bigger, but this server is intended to be used for local development. We will start it very soon. So for most use cases, the local and the cloud server should be enough for everybody, I believe, in general. But of course, you can define your own custom profiles, and you can switch between them or create new ones. This is meaningful if you have your custom Golem installation somewhere. But for now, for the demo, we will use local and later cloud. And of course, you can switch between these profiles by either using the profile flag, but because the local and the cloud is so common, we can also just say local or cloud anytime, or just use the shorthand forms like -C or -L, and this will, in any command which needs to touch any server, will automatically use the profile you are referencing. And of course, we also provide environment variables called Golem profile if you want to use it for, like, I don't know, CI reasons, or you cannot use these flags. Now, now that we did this, I will, of course, unfortunately, repeat some parts what Daniel did in the previous demo, but mostly I will, as I said, focus on other combinations of these commands and flags. So let's create a Golem application, just like before. And one thing I would like to show you that many commands in the Golem CLI, of course, have help, and you can specify all the parameters. But for common ones like creating a new application, we also included an interactive wizard. So you can just say, I will use Golem demo. And of course, I will use TypeScript because that's the language we offer. And I will just use the default counter example because the main point of this session is about how to change that code. And I will use up component. Of course, you can use your actual project name in this case, and we can see it will create the application just like before in the previous demo. It will detect automatically that it should install all the relevant NPM modules. And it's important because this is how we give you both libraries that you can call and also part of the SDK. If you watch here at the end, you can see that we have application component, it created, and it tells us that we probably should switch to this library. Let's do so. Let's check. Yes, we actually have a new directory, switch to it. And I will use IntelliJ IDEA for this demo, but Visual Studio Code should also work. Usually we test with both that our projects are understandable by these IDEs and you get code completion and such features. As Viggo mentioned, we have a first might be scary layout of the project, but again, this is for supporting more complex setups and later for more language support. But usually what you want to focus is the components TypeScript folder, and you can see it created my component directory where most of the development will happen inside in this main TS file. And of course, I can define as many agents as you could see in the demo, and I can do it in multiple files. But for now, I will just stick with this simple ones. I also want to highlight that the aforementioned Golem YAML files, which are used, for example, defining HTTP definitions, almost all of our templates, I believe, actually all of them will contain definitions, and you can see it can be deployed locally. So you will have enough to start exploring how to create HTTP APIs, but also you can follow the links we added. And as it was shown, we also include all the common keys or the common dependencies you might have to use for the LLM or for the AI dependency to be working. And another thing I want to highlight is that if your IDE is configured currently and working currently, we also offer a JSON schema. This can be useful when you want to just explore around what options are available. You can see this means I have code completion even on the manifest file, and I can dig into stuff easily and have a little bit short of description. For example, the aforementioned profiles can be also configured and customized in my application project. So if I want to customize, for example, the built-in local profile, I can do things like change those reset flags, or we have offer others, one like redeploying just parts of the HTTP or redeploying everything. I will talk about more about this. Auto-confirm, you can change what is the default profile used for this specific application, and so on. And this is a nice way, for example, making sure that I will show you these flags later. You might want to use them usually with your local, or you have a specific environment where it makes sense. But for now, I will not use this. Rather, I will show how to use these flags. And before we start, as I said, the Golem executable also embeds a whole nice Golem server, which is ready to go. And if you check the command line arguments, I want to highlight two of them. So when you run Golem server run, it will use one of your operating system specific main data directory. So this is by default, it will use a common place to start your server. And sometimes you want to get rid of it. So you can just use the clean flag. This will wipe out everything and start from fresh. And of course, this might be inconvenient if you actually want to keep the durable state around, and you might want to use it for tests, or you actually want to have the data. You can use the data dir option, where you can, for example, put next to your project IO data, and this way make it durable and not mixing different projects even locally. For now, I will just use the Golem server run with the clean flag, and it's already started quickly, so we can go back. As you would see in the previous demo, one of the main commands we want to use is Golem up and build. So just like before, this will execute different internal and TypeScript-specific steps to create our components. And as you see, it created my deployable components. But once again, I would like to highlight that anytime you run Golem up build again, this time it was very fast, because all of our build steps are using an internal check whether the sources and targets are up to date. So you shouldn't be afraid to frequently call Golem up build, even as part of your local workflow. Anytime, only the parts, only the components will be rebuilt, only the source code that's changed will be reorganized or compiled into components. And to prove this, I will just make a little bit of change. Let's go wide and increment by 2 instead of 1. And you can see that it detected that, yes, I changed my source code, and it rebuilt all these things. Another thing which you could see in the previous demo, that for deploying, and by default, it will target my local environment. So if I call Golem deploy, one thing to notice is that deploy always implicitly calls build. And we do so because what we want to achieve is that anytime you say deploy, the code you have in your repository should be the same as you expect to be deployed. So if there anything changed, then this will trigger a build, and that will create differences, and we will deploy that. You can see it deployed my component, it deployed my HTTP API definitions. And let's say I change this code again and deploy again. Now we see that it triggered the build process. And it detected that, yes, the hash of the component changed. This means we have to create a new component version. So it started with 0, now we have 1. And it also created a new HTTP definition, because in HTTP definitions, we implicitly try to use the latest version of these components and agents. And you can see, because in production, many times, of course, you do not want to just blindly drop an old API or overwrite an API with the same version. It asks you to specify a new API version, which will actually bump this version inside the YAML. And this makes sense for production environments, but not so when I'm just trying to develop locally. So instead of that, what I usually recommend, let's just cancel this. You see, we can cancel it. The aforementioned reset flag can be used to basically drop everything away. So one thing to notice that it's one thing to drop away HTTP APIs, but as we mentioned before, our agents are durable. So if we deploy a new version of a component which includes new agent definitions, that doesn't mean that all the existing agents are updated automatically. We can ask for that explicitly one by one or as part of the deploy. Or what I think the best thing to do locally is just usually, if you do not need the previous state, just simply call reset. And this time it will still ask you for confirmation. And you can see that there is a not so secret flag to do so. And we can, if we apply the yes flag, this will respond as yes automatically to any auto-confirm questions. And if you like short flags like me, you can just say, yes, really reset all of this stuff. And you can see everything got, so if there were changes, we rebuild the stuff, we deleted all the previous deployments or HTTP APIs. And if there were any agents already running, those would have been deleted and then recreated. Now, this already, I believe, a nice improvement to know that you can just usually rely on deploy. But as you saw, there was one way how Daniel interacted with our component, which is the Golem REPL. I would like to show you another one, which is Golem agent invoke. And again, another thing, if you do not know what to do, I recommend sometimes just explore around. For example, if you use Golem up without any subcommands or parameters and you run it, what you will see is that apart from showing you the basic command help and the subcommands and the flags, it is also context aware and will tell you, for example, that, hey, in this directory, we have this component, we have this API. So you can just poke around and see a little bit more your application-specific context. So as for calling an agent with the invoke method, invoke subcommand, let's try to do this. It will tell you that you should somehow tell the agent ID, which is the agent constructor, and the function name. And usually it also tells you that the fully specified agent name is by the component and the agent, but the CLI mostly smart about if there is only one component inside the project, I should only define the agent name and the component name is implicit. So again, if I forget what kind of agents are allowed, I just use a bad one. And the CLI will tell me that, yeah, the upcomp will be the component I'm using, but there is no such a thing as XYZ agent. But it will tell you that, hey, you probably want to use something like this. Let's do that. And now I will try to invoke this agent. And again, I will make a mistake. I will use, let's say, not use that parameter it was provided for me in the help. And it will tell me that, there should have been one parameter. So again, it's okay to make mistakes. The CLI will teach you what to do. And then let's use an actual string now. It tells us that we are already there, very close. The only thing missing for us is the function name. And as Daniel said, there are technical reasons for now why we are not using the actual TypeScript names here. So for now, we are using this with component interface, fully qualified names. But again, the CLI is smart enough and uses fuzzy search. So usually you don't have to remember all of it. And you can just say, let's say inc or increment, and you will see that the CLI fuzzy matched the inc because it was there were no other candidates, and if it's obvious, it will do the right thing. Now, when we use Golem agent invoke, and you could see it before, if you use it the first time and on the target server, which is defined by the profile, the component is not found, it will ask you whether you want to deploy it. But after that, just by accidentally, it will not keep deploying all these things. So which makes sense because usually you do not want to destroy your environment. But locally, it might be that I want to iterate on my design. And let's say I will add the very silly and the very small function, which just a hello word, really. Hopefully the AI can write it. Yes, it managed to do so. So it will return hello name. And let's say I try to call this. If I try to call this, this will not succeed because I do not have this component deployed. But the good news that all those flags, which you can set in the profile to use default. So these include the redeploy agents, redeploy HTTP API, update agents, but my favorite for the local flow is reset. If I define any of the deployment related flags on an invocation, it will also do a deploy, which will implicitly do a build step. So I can just do quick developer loops using one command. So I will do a name here. And you can see it triggered the build, it will ask me for if I really want to delete my agent. Yes, I want. And now we have a result. And again, just so let's check what functions, sorry. Let's check quickly what functions we have. If I use a wrong name. So we have the hello function, and I want to keep calling this one. But with, as I said, I want to always have a fresh environment, and I always want to auto-approve this, and I want to call the hello function with a name. And it will return hello name. Let's say I iterate a little bit. Sometimes we code a lot, but sometimes we just want to adjust a little bit of thing and want to see whether this is happening or not. And with a few flags, I can do so. Again, build, deploy, replace all my agents, and hopefully it will show all these beautiful exclamation marks for me. And so Daniel used the Golem REPL. Let me just say that the Golem REPL has the same features. If the component is missing, it will deploy on the first try. And otherwise, you can also use reset and redeploy and all these nice flags. And also would like to highlight that you could, if you well, sorry, even before that. So the Golem REPL is also smart enough. If there is one component, it will automatically select it. And one thing you should rely a lot on the REPL is auto-completion. So instead of relying on CLI errors, it's really nice that I can just, if I want a simple example, I can just keep pressing the double sorry, not this function, but the hello one. And it will just, I think, is a really, really joyful way to explore the system very quickly, especially if you have to jump around different projects or applications and agents. And now all of it is working. And also the REPL, if you want to automate a little bit, let's say some simple smoke test, we offer also a script where you can just inline your REPL test and then run it exactly, or use the script file flag and store your REP script in a file. No, this is all nice and good to actually quickly change my code and have a feedback loop. But also sometimes I would like to see what is happening inside of it. So we saw a way of it, which was the uplog stream, which is Golem agent stream. And this will require an agent ID, which I forgot. So let's just list them. We can see we have now one created from the invoke, one created from the REPL. So let's stream from here. And we can see it has the basic log, but because we didn't use console log at all, there's nothing much exciting. Now let's combine with invoke this. The invoke also has a function, a flag called stream. So we not just invoke, we also connect at the same time. And again, I will say yes, I will say reset. I combine all my knowledge of the CLI. And of course, now that I'm invoking, I should specify an actual function. And I will, again, specify a name. Let's see what happens. And one thing I will change, or let's call it like this first. you see, this is the stream we have here. But also, if I'm just adding some debugging, I mean, that happens. Sometimes you just want a good old debug by print. I will do it so. And if I rerun the previous command, I'm compiling and deploying and invoking and also streaming at the same time. And now I can see my, and when I'm done, I just remove it and move along and do other stuff and fix my code. And I also want to mention very briefly and very quickly that we also have Golem agent upload. And that will give you a very, I don't want to show it now, but it will give you a very detailed and beautiful list of all the host functions happening behind the scenes, all the AI libraries you are calling, all the interesting things, all the invokes your agents are having. And that's a great source of debug tool. And we will see more of it in the next section. And the last part I would like to tell you about is that so far what we see was mostly text output. And as I showed, you can define different output ones, both in the profile, as part of the profile in the manifest, or if I just say Golem component list, you see this is a nicely formatted text output, but we also offer a few other formats, including JSON, which is not very nice, but it's intended to be used by other tools. Or if you don't have a JQ installed at hand, you can just, we have a built-in pretty JSON for you, and you can have a nice colorized pretty printed version. And the same goes for YAML and pretty YAML. Another thing I want to show that if you want to feed these things into tools, you might want to use, let's say, JSON format. You will notice that sometimes you will still have output, but very not, because anytime you are using a specific JSON or YAML format, we will split our output. Any high-level logging message will go to the standard error. All the other stuff will go into the standard output. So it's perfectly fine to pipe this output, let's say, JQ, and you see it will not die on bad input because these are separate output. But if you prefer not to see even that, we offer, you can easily silence stuff. And this way, it's easy to combine. Now, if we combine all what we did before, you can say that have this stream, it reset, yes, and you might even change the format to JSON and stream it to JQ, and then you can have some flags on it. This means it makes it very, very easy to create a small smoke test script as one-liners, where you can just quickly make sure that the latest version is deployed locally, check it, and run it. Now, all I did was happened locally. And as I mentioned, we have a built-in cloud profile. And ideally, all we have to do now, once you feel like you are done with your deployment or your application, you can just say Golem deploy. But this time, and as I said, many commands, including the deploy one, will actually understand the cloud flag. Let's see if it works. I'm really excited that our latest deployment is happening currently. But you will notice that this will take a bit more time because, for example, it uses different profiles. And also because, of course, the server is not running locally and it was communicating with the Golem cloud. But as you can see, it happened. And I really hope if I go to console Golem cloud and I log in very quickly. Yes, so I have these components which we did before. You can see these were the ones I was creating, and some of which were created before while I was preparing. Now, these were the main things I wanted to show you very quickly, and I encourage everybody to start exploring alone and also visit our website, and especially the subsite, the learn.golem.cloud, and also visit our Discord, ask around if you have problems around how to explore, how to build stuff. And now I will give it the word to Andrew, who will talk more about our Golem Cloud Console.
Thank you, David. Yep, my name's Andrew, and I'll give a brief overview of the Golem console, which is the web front end. So let me share my screen here. Okay, this is the console. which is a front end for your components and projects. This is all managed by the command line. Most of what you do here is read-only. You're not really meant to manage certain things in the console. So I'll go ahead and show you. On this view, you can see I have one project already created. There's some links to resources down here if you need quick documentation references. I'm already logged in. You'll have to log in the first time you visit, but I'll go ahead and show the project view here. So on the project view, you get a view of all of the components that you've created, as well as the APIs. I will go ahead and show the components view. This is a component that I've already created using the command line commands that you've already seen. As you can see, it shows the exports, which are the methods that you define on your agent. This counter agent demo comes from the template, the counter agent template that we have. And I've already got one active worker here, but I'll show you creating a new worker is possible from the console. It's this button here. You can select the component types from this drop down here, and you can see this is the counter agent demo. Agent type, counter agent. So this is a dynamically rendered form, so it's based on the constructor parameters that you have. Our counter agent just takes a name, so I'm going to go ahead and just call this demo 3 and create this agent. And you can see whenever an agent is created, it takes you to the agent dashboard here, which is what we're seeing now. It gives you some information like the status of your agent, the memory usage, resource count, and when it was created. You also get a view of how many live invocations and what methods were actually called, and a view of the live terminal. If there was anything to show, it would show here in live terminal view. So you can also see the live terminal here on this side nav menu called live. It has these 3 views here, which you can see invocations here. This initialize function is always called to initialize your agent. If there were any console logs, application logs, they would show up here. So to demonstrate that, you can invoke your agent, any of the methods on your agent from this invoke tab here. So if I select my agent, it has this increment method, which is, again, it's code first. So this is just a TypeScript method that's defined on the actual code itself. You can see it increases the count by 1, returns a new value. So if I click this invoke, you can see here, this the value is now 1 for the template comes with. Basically, it's a stateful increment agent. It just increases this value. So if I were to call it again, you can see the new value is 2, and so on. If I were to refresh this page, again, this is all stored stateful. So if I invoke this again, you can see we're up to 3 now. So you can invoke from here or the CLI. You've already seen the CLI invoking a worker. I would like to show you in the console, we can actually, there's a few interesting features here in the console to help you with debugging. First is the recovery screen. So if your worker ever encounters an issue and you need to go back to a certain point in the invocations, you can actually revert your worker back to a previous state just by clicking one of these buttons here. It'll recover your worker back before that point. So the state of our worker right now, as you can see, we're currently up to 4 in our stateful worker, but if we wanted to go back, and you can see that I just invoked it, and this just popped up again as an invocation that we've done, calling the increment function here. If we wanted to go back, for example, before I invoked it for the first time, I could click this button here, and our agent is rewinded to before that was called. So if I go back to invoke now, increment, and I call it again, I just incremented from the initial state, which was 1. So this incremented it to the value 2. So as you can see, now we're back to just having incremented once. So this can be really useful if your worker, if your agent gets into a exceptional state and you need to recover it. You'll see the state of your worker up here. Currently it's idle, it's not running anything, but it may be in a failed state. If it is in a failed state, you can always recover it by using this recovery feature. Likewise, we have a a debugger as well. This is basically a standard style of debugger. You can set breakpoints and step forward to those breakpoints. So for example, it's currently it's currently just paused at the completed state. If I wanted to stop right here at the end of this exported function, which is the increment function, I could set a breakpoint right here and click the step forward button here, and it would step forward to the end of this function and put the state there. So then if I invoked my agent by using this invocation tab, at that point, it would increment the value from whatever state that was at. So this can be useful for debugging as well. Just checking what the actual exported function invocations are. You can see every time I invoked the increment function, there's a log here for that. Clicking on any of these items also expands to the full, basically up log items that were done for that invocation. I believe that's pretty much all there is to show for agents. There are some other features that you can explore in the console, but it's currently under active development, so please let us know if you run into any issues. With that, I'll hand it back to Daniel.
Thank you. Yeah, so I'm just wrapping it up. John already had to leave. I hope that you've seen that we are really excited about this new release, and we really try to improve the user experience, developer experience when using Golem to implement your own agents. And yeah, if you liked anything that you've seen, I encourage you to try it out. Please check our website, thegolem.cloud, and yeah, please, if you have any kind of feedback or feature request or bug report, then let us know either on our Discord or as a GitHub issue or in any other way. And thanks for watching our demos. See you online.